In this short video tutorial, we're going to cover the topic of securing your assets. In particular, how do we secure our client-side and server-side API requests. Each of these categories have a very distinct way of securing the request. For client-side, it's a simple process of enabling all the domains where you would expect your client-side API calls to originate from. We would require them to have them authorized or enabled against your client ID. For server-side requests, we would require you to create a digital signature to be sent in along with the original request. This digital signature will be created with the help of the cryptographic key that would have already been provided to you in the welcome letter. Now, the examples here show you the usage of how to make these calls with the necessary information. If you notice, for the client-side request, all you need is the client ID. We don't have to worry about the domain because they would have already been enabled against your client ID. And one of the most straightforward ways to do this would be to make use of the support portal and listing down your domains against your client ID. For server-side requests, we're going to take a look at the details step by step to creating the digital signatures. Like I mentioned, for client-side requests, the easiest, most straightforward way will be to make use of the support portal to list your domains. So this is a URL for logging into the support portal. For those of you who haven't been into the support portal lately, you would notice that the left-hand panel has been modified, and now we have a link that's called Maps Configure URLs. This is where you would go in and add the domains that you would need to enable against your client ID. In the past, this would have required you to file a support ticket, but now we have a section where our customers can make use of this link in the support portal and list down their own domains. This process does not take too long to verify. At the back end, it's pretty instant. So the moment you save the URLs, it's just a matter of time before they get picked up and get configured and enabled against your client ID. Couple of things you want to take note of when adding in your domains. So be very specific with the protocol. HTTP is not equal to HTTPS, and if you want to enable a particular domain that has a particular directory or a port attached to it, all other port numbers will not be enabled against that client ID. Only the port that you would provide as input will be enabled against that client ID of yours. If you provide a domain without being particular about a certain port, then all the ports will be validated and enabled against that client ID. So that was how we go about securing our client-side requests. Some people may be worried about the fact that we provide our client ID in all these requests. What if anybody else decides to pick it up and use it for their own mapping application? That's where the listing of the domains against your client ID becomes handy. Those requests, even though they make use of your client ID, would be originating from their own domains which are not mapped against your client ID. So they will not be able to make use of your client ID or eat up any of your page views or quotas tied up to your client ID. The next thing we're going to take a look at would be how to secure our server-side requests. For server-side, we do not require you to send in the request from domains that have to be enabled against your client ID, because these could, depending on the kind of request, we could have a request for geocoding 10,000 addresses, and they need not necessarily come from a domain where you're hosting your mapping application. This could be, the addresses could be in a database residing on one of your Linux servers. We have a lot of flexibility there. We do not require to list down the IP addresses or domains against the client ID. So the way we're gonna secure these server-side requests will be with the usage of a digital signature. In order to create this digital signature, we would need your client ID, which is part of the welcome letter. We will need your cryptographic key, which is available in the welcome letter. and of course the request that you're sending in. It could be a geocoding request, a request for directions between 2 points, or it could be request for a static maps API image. Whatever the request is, one of the prerequisites for creating a digital signature would be that this original request be in a valid URL format. As an example, if you have certain Japanese characters in the original request, you would need to make sure that it's converted into a URL encoded format as shown on this slide. This slide kind of gives a summary of how do we go about creating digital signature. Like I mentioned, the key ingredients that go into creating your digital signature are your cryptographic key, the original URL that you're going to be sending in as a request. And these two ingredients are passed to the hashing algorithm, which will help us create a unique digital signature for that request. So this step will have to be repeated for every unique request that you intend to make a call for. For instance, if you're making a geocoding request for 2 different textual addresses, you will need to run this process twice. Each of them will result in a very unique digital request. Okay, before we go further and describe the steps in detail, we will just highlight one thing about cryptographic key. This key is not the digital signature that we're talking about. In fact, it is an ingredient that goes into creating a digital signature. So do not ever use the cryptographic key in its original format. Do not share it out. It is very much to be treated like a password, so you don't share it out. You don't send it out with any of your client-side requests. It is only required when you need to digitally sign your server-side requests. So the way to use it would be to input it as an argument, as one of the key arguments for your hashing algorithm along with the original request, and that would help create a digital signature. Also, there typically is some confusion between the crypto key and the other terminology that use the word key. For instance, Maps API key, Dev console key. So this crypto key is very different from all these other keys. The other keys that I mentioned just now can be used and supplied in the request in one form or another, but the cryptographic key is never meant to be used directly. It is used to create a digital signature which you will append to your original request before sending it out. So to very quickly summarize, for client-side requests, we will have the domains from where we're expecting the request to originate to be enabled and authorized against your client ID. And with the help of the support portal, now you can log in and directly list down all the domains against your client ID and have them verified. For server-side requests, we need to create digital signature for each unique request. So we're going to take a look at a demo with the help of an example call to Static Maps API to highlight the key steps that go into creating the digital signature. The Static Maps API, when called, will retrieve static image for a particular location respecting the size and various other parameters that we have supplied as input. If you want to take a look at the documentation on Static Maps API, you could follow this URL, but essentially what this Static Maps API does is, given the location as the center parameter provided as input, it will display a static map image of that location as the center within the size limits that you would provide also as input. Another thing you want to take note of is the limits that apply for free versus Maps API for business customers. For free, it's 640 by 640 versus 2048 for Maps API for business customers. Why are these limits important? Because even as a Maps API for business customer, you can get away with making a static Maps API call without providing your client ID, as long as you're not exceeding the 640 by 640 limit. However, that kind of call will not be registered as a premier call and you will not be under SLA. However, if you were to make a call irrespective of the limit with the client ID, the other ingredient or parameter that we would expect in the original call would be the digital signature. So putting that as an example, take a look at this static maps API call. We have the center parameter, the zoom value, and the size parameter. Since we're not exceeding the size limits for free API, we could easily make this call just for the purpose of demo without making use of a client ID. And what you see as a result is what we would expect: the static map image of the location centered on whatever has been provided as input in this static maps API call. In the example on this slide, notice two things have changed. We have changed the size parameter to the maximum limit for static maps API, which only can be done if you are a Maps API for business customer. And along with that, we have also appended the client ID. If we had not changed the size limit, would it be necessary to provide the client ID or vice versa? So the easiest way to answer is, like I mentioned just now, irrespective of whether you provide, irrespective of the size, as a premier customer, you are always recommended to use the client ID. However, if you do not exceed the free API size limit, you could get away without the client ID, but you will not be protected by the SLA. If you intend to use sizes bigger than 640 by 640, you will not only need the client ID, because this example clearly shows that if you were to submit a request just the way it is, it would result in an error, simply because you're missing one more parameter here, which is the digital signature. And the next few slides are going to be going through the step-by-step of how to go about creating a digital signature. We could have also done this with the example of a geocoding request, but with the static maps API, it just becomes a little bit simpler. We will definitely revisit the geocoding example after we cover the steps in detail. The step-by-step for creating a digital signature are covered in the next 2 or 3 slides. We'll start with step 1, where we take the original request, which is HTTP maps Google APIs.com, and you see here that this is the original request that we highlighted in the previous slide. One of the things you want to make sure is, along with the other parameters that would be necessary for that particular API, for example, if it's static maps, we need the center parameter, the size parameter, zoom parameter. The other essential parameters would be sensor and client. A lot of people sometimes make the mistake of not putting the client ID in this request because they think it will be a separate arguments applied to the hashing algorithm. So that's not correct. The client, this is the only place you will provide the client ID as part of the original request. Now we don't really need the protocol and the domain part. So as part of step 1, that's what we're going to do. We're going to strip off the domain and protocol part, leaving us with the name of the particular API we're trying to make use of, along with the other parameters supplied as input. So we will start from /maps/API static maps, followed by all the parameters provided in as input. So that is our step number 1. Step number 2 talks about the other key ingredient, which is our cryptographic key. Like I mentioned earlier, this is available in your welcome letter. However, the key that is provided in your welcome letter is in an encoded format, so we cannot use it the way it is. We will have to decode it. There are 2 steps to achieving this result. Step 1 would be to convert this crypto key into base 64 encoding. That's as simple as writing a script that will replace the hyphens and the underscores with plus and / signs respectively. The second part of this step would be to convert the output of step 1, which is the base 4 encoding format, into a binary format. This can easily be done using available functions, depending on whichever programming language you're most comfortable in. Most of these programming languages always have a function to do this particular step. Now that we have the modified requests and the decoded crypto key, we're ready to use them in the algorithm to go about creating a signature. So that's our step number 3. We provide the decoded key and the path, which is the modified original request. as input to our algorithm, the end result of which is a signature. Now we want to make sure we understand that this signature is in a raw format, so we are not to use this directly. We need to convert this into a format that we can append to the original request. Now the steps to do this are the exact opposite of step number 2 that we just took a look at for converting your crypto key into a decoded format. So we're going to be doing the exact opposite of that. We're going to be converting the raw signature into a base64 encoding format and further make it URL safe by replacing the plus and slashes, the plus with hyphens and slashes with underscores. At the end of this step, what we will have is a valid digital signature to be used with the original request that we started off this example with. Please do take note that the request, even though we stripped off the domain and protocol, is very much a key ingredient for creating the digital request. So please do not shuffle or change the placement or ordering of the parameters. If you do that, then it would render the current signature as invalid, and you will have to follow the same 5 steps to creating a very different digital signature for that modified request. If you keep the original request as it is, all you need to do is append the digital signature at the end of the 5-step process to the original request and send in your requests. And as you would expect, this time around the request would work, and what you see as a result is the static map image with the specifications you provided as input. For example, the size parameter 2048 by 2048. You can make this example more interesting by changing the parameters and following through the steps and see if the existing signature would work, or you would have to follow the same 5 steps to creating a whole new digital signature. And we kind of highlight that point in this next example. So in this example, we make use of the geocoding API to do forward geocoding. So what goes in as input are the address, the sensor parameter, and of course the client ID. We will, as step number 1, we will need to strip off the domain and protocol part of this request. However, for step number 2, if you still have the decoded version of your crypto key, you're all set for step number 2. In fact, most of the time we recommend people to, if they consider it as a saving, to have the decoded version of your crypto key saved somewhere private. And so step number 2 becomes as easy as referring to that source for the decoded version of your key, because it's the same key being used over and over again as an ingredient to creating your digital signature. The only thing that changes frequently would be your requests, even though we're talking about the same request. For instance, in this example, I'm trying to find the geocode for New York, but in my second geocoding request, I could be trying to find out the geocode for a street address in Los Angeles. Since that would change the original request, that would mean that I would have a completely different digital signature for second request compared to the first request. The rest of the steps are pretty straightforward. Once you're done with the decoding of the key, you would provide as input the modified request and the decoded key into the hashing algorithm, arrive at your raw signature. You would have to re-encode it back into a format that you could use. So that would be base64 and making it URL safe. Final step would be appending the digital signature to the original request. All right, let's wrap up the discussion on digital signature by taking a look at some of the examples that have been published on the Maps API documentation under our developer site. As I mentioned earlier, we have a bunch of samples written in various programming languages, and you can follow any of them depending on whichever language you're comfortable with. Another good thing about these samples is they include all the necessary libraries, functions, and routines that take care of some of the things that were discussed earlier in the various steps for creating a digital signature. For instance, if we take a look at the Python script right here, you don't have to worry about doing the conversion of your crypto key into a binary format or stripping off the domain and protocol part from a URL. All these are taken care of by existing functions and libraries that are built into most of these programming languages. Now, my favorite example is the Python example because it's pretty straightforward to use. In fact, the only two things that you need to modify in this Python script are the URL, that will be your request, be it geocoding, static maps, directions, whatsoever. The second thing you need to modify is right here. You need to replace this string with the original cryptographic key that was sent to you, which is available in your welcome letter. So based on what we've discussed so far, the only thing that will continue changing in this script would be the URL, because with every unique request you will have to modify this part. So you can make it you can rewrite this code so that it accepts this URL as an input, or you could open up this file and edit this one particular line every time you want to create a digital request for every unique URL. The cryptographic key part, however, remains the same. And I mentioned earlier there are functions that take care of decoding your crypto key into binary and re-encoding back the raw signature into an encoded format. All those are done by built-in functions. And so this one particular function does the decoding of your crypto key. Right here, the other function takes care of encoding your raw signature into a format that can be easily appended to the original request. Now, if I was to implement this on my machine, it will look something like this. Right here is a copy of the Python script that we saw on the documentation site. The only things that I've modified are right here. I will highlight them. So this is the original URL, which is the geocoding request I'm making. And here is the second modification I made, which is the cryptographic key available from the welcome letter. Also take note that we need the client ID to be supplied as part of the original request, so don't forget that. So put in the request as it is. You don't have to worry about taking off the domain or the protocol part. That's taken care of by the built-in functions in each of these programming languages. So having modified these two, all I need to do is run this script, and the script is designed to print out as output the modified URL after appending the digital signature that would have been created by running the script. So right here is what has been appended as the last step by this Python script. I see the signature, and if this were a valid client ID, because this is only for demo purposes, all I need to do is copy paste this modified URL into a browser, and I'd be able to see as output, based on this geocoding request, the geocodes available for the address New York. Let me just browse down the documentation side and point you to codes that are available in other programming languages such as Java, C#, and there's various other examples if you're looking for other programming languages by following this link right here. For those of you who are more comfortable doing programming in Java, let's take a look at the Java example for creation of digital signatures. Again, just like with the Python example, the parts that do the encoding and decoding of your cryptographic key and this raw signature have already been done. So that's the good news, and all you got to do is make use of these existing classes to get those steps done. However, for this Java example, there is one assumption right here. be sure to include this particular base64 encoding class in your class path. This example assumes that that has been done for this example to work. If you have done that part, all you need to do is simply copy paste this whole script into your Java file, and the only two things that you need to modify are, again, the cryptographic key and the original URL that would require the signature to be appended to it. Another thing that differentiates the Java example from the Python is in Java, it's much more straightforward and easier to do exception handling. So in this particular example, they've included exception handling for keys that may not be valid, or URL syntax that may not be according to the terms under the valid URL terms that have been listed on the documentation for the Maps API digital signature creation link. The output of this Java example is very much the same as with the Python example. It will take the original URL and append the signature that has been converted from raw signature that's been generated, that will be created along the course of this program, and will be appended after converting it into the base64 format. And the key piece of code in this program is right here, where the path is being provided as input along with the query items such as the sensor, the client ID, and so on and so forth that goes into your request. And as output, what we print through this program is the complete URL, including the protocol and the domain part, plus the request that has been modified in the previous step. So this step would append the generated signature together with the original query that was provided as input. Some of the classes you want to take note of are right here. This is the class we use to do the creation of the raw signature. This calls the hashing algorithm. And there's one more class right here that is doing the encoding of the raw signature back into the base64 mode. This assumes that you have included in your class path this base64 encoding class. Okay, so let's summarize the discussion we did in this video. We took a look at two main things: securing your client-side APIs and server-side API calls. Let's start with client-side. For client-side, we took a look at how to go about securing these requests, and it's a simple process of having the domains from where you would expect these requests to originate listed against your client ID. And the process to achieve this was by going into your support portal, making use of the relatively new link that's been added to the left-hand side panel, going inside that link and listing all the domains that you'd expect your request to originate from, and have them enable against your client ID. We do not mention or do not need to include digital signature when it comes to securing your client-side requests. When it comes to your server-side requests, each request will have a unique signature. We took a look at the 5 steps to creating a digital signature. Some of the key things that go into creation of your digital signature are your client ID, your cryptographic key, and the other parameters that go inside your request. Also take note of the fact that even if we're talking about the same kind of request, for instance, we're making 10 geocoding requests for 10 different addresses, each of these calls would be different because the addresses that you would be providing as input will be different. So each of them will have a unique digital signature that has to be appended together with the original requests for your request to work.